Today we're talking about coercion and truthiness. This is something that is going to be mildly annoying because it is kind of it's one of those like small things that's always there in the background, whether or not you actively are aware. And so it's better to be aware than to not be aware. So it may seem a bit kind of like annoying what we're doing, but just recognize that this is going to be part of almost every block of code that you read from here on out. So coercion and truthiness. One of the things that we've kind of talked about on the edges is just their types, their data types in JavaScript. Types are, I don't know how to describe a type beyond just using this word type, but they're the different formats of data that we've seen. So we've seen numbers, we've seen strings, we've seen booleans, which are true and false. And we call these data types primitive data types. There's a few other primitive data types too. There's something called null, there's something called undefined, and there's something called symbols. But we touch on those a lot less. For now, let's keep our attention on numbers, strings, and booleans. We call them primitives because they are not changeable. And in a later section, when we talk about pass by reference versus pass by values, we'll come back to what it means for a data type to be primitive. But for now, just know that the numbers and the strings and the booleans that we're going to talk about, these are the three main data points that's going to be the focus of today's lecture. Okay. If we have primitive data types, then that means there also needs to be non-primitive data types. We don't call them non-primitives generally, we call them complex, or we call them object types. And these include functions, arrays, and objects. And we'll cover each of these, the functions, the arrays, and the objects in way more detail in future lectures. We just wanted to let you know that these exist, but don't get too hung up on necessarily what they are and kind of what they do. Yeah. So when we have data types like a string, a number, or a boolean, usually we use a number like a number, a string like a string, and a boolean like a boolean. However, there are times in which we actually want to change a particular piece of data between different data types. And so coercion, and just colloquially in English, it means to change something into another type or another thing, right? And so in JavaScript or in programming in general, coercion is actually a very common practice, which basically means we take a piece of data and we change it to another type of data. Sorry, rather, we take one data type and we change it to another data type. That's all coercion is. We're changing something from one data type to another data type. Coercion comes in several flavors. The one that we'll cover first is something called explicit coercion, and it's, as the name indicates, it's explicit, which means it's very, very clear what we're doing. Explicit coercion basically means we are taking one particular data value and we are very clearly, very manually changing it to another data type. So what does that mean? In the example here on line 6, we create a variable called num and um, and we set it equal to 10. Between all of us, we know that 10 is a number, right? And so on line 7, when I console log out type of, this type of operator, notice how it's all in lowercase, it's not camel case. That's because this is also a reserved word in JavaScript. So that's why it isn't camel case. Type of is not something that I create, it's something that exists inherently in JavaScript. And when you do type of something and put a variable after it, it will quite simply just tell you what type that value is. So on line 6, after I create num equals 10, on line 7, when I console.logout type of num, I get number, that first line up here on top right hand corner of my screen. Because why? Because 10 is a number type, right? On line 9, you'll notice how we create a new variable called lowercase string, string, and we set it equal to this capital string. And notice how we have open and close parentheses after the string. Basically, we're invoking it. We're calling it like it's a function, and we're passing in num. Notice how the s in the string on the right-hand side of the equation is capitalized. So remember yesterday how I briefly mentioned, or sorry, on Monday when I briefly mentioned, usually all variables are lowercase. Usually when the first letter of a variable is uppercase, it actually means we're talking about a class. Well, without going too far into what classes are in detail, just know that things like number, boolean, and string, as in all capitalized, those are built-in JavaScript data types, and so they have built-in classes associated with them. And so on line 9, what I'm really saying is I'm saying, hey, let's put num, this variable, into the string class. And what the string class is going to do is it's going to take that number and it's going to try converting it into a string for me. So on line 10, when console log out string, I actually, lowercase string, on line 10, I actually print out something called 10, which you also see in the right-hand corner of my screen. But when I do type of string, I actually get back string because the type of it is now a string rather than a number. One of the things that we didn't show here is that if I was to console log out type of num, again on line 12, we didn't change num, so type of num is still going to be a number. In line 9, all we did is saying, hey, here's this variable called num. Can you make a string version of this value for me? And the string class will try its best to make a string value for you while preserving the value. So let's take a look at what happens when we try to do the reverse, right? And this might be a little bit more clear. Let's say on line 6, I create a variable called string, and I set it equal to a string. Notice how on line 6, that is not a number. That is a string, as in it is a string with 4 characters. The first character happens to be 1 and then 0, 0, 0. So it's a string with 4 characters. And when I do type of on line 7, I get back a string. On line 9, what I then do is I say, hey, take that string value, let's now feed it into the number class, right? So I have capital N, which indicates I'm using this number class. I pass in string, and I store whatever number gives back to me in this num variable. Once again, what the number class will do is it will receive the string and do its absolute best to convert it into a number for me. And then whatever value it gives back, I store in the num variable. So on line 10, when I console log out num, I get back 1,000. And when I console log out type of num, it is a number. And so that's why I say it's 1,000 now. It's not a string of 1000. It's now a number because on line 9, I converted it into I created a new thing in the number class, or at a number class, convert that string for me into a number. So a little bit kind of roundabout way for me to verbally explain it, but hopefully the slide makes it a little bit more clear. Kind of what we're doing here. All we're doing is taking one value that's in one data type and trying our best to have that class change it for us into another data type. Oh, sorry. Any questions here? This makes sense? Makes sense, everyone? Okay, so we call this explicit coercion because on line 9, once again, right, we're very clear, hey, I'm going to change this into a number class, right? Like that capital N for number, that means that it's explicit. Going back on the previous slide, that capital S in string, that's explicit because we're saying, hey, I'm going to change whatever it is you're going to give me into a string or into a number. There's also something called implicit coercion, which is something that we do when we change data types, but we're not as clear, we're not as explicit with what we're changing. So it behaves in exactly the same way in that we are still changing a data point from one data type to another data type, but there's a little bit more kind of things happening underneath the hood, and so it's really important that we understand what's happening. So here on line 1, I have let's sum equals, and I have two numbers, 10 and 20. When I add them up, I get 30. Pretty clear. On line 3, I have something called concatenated string, and notice here I'm setting equal to the string of 1, 0 plus the string of 2, 0. And so on line 1, when I add up 10 plus 20 as numbers, I get back 30. On line 3, when I add a string of 1, 0 plus a string of 2, 0, I get back a string of 1, 0, 2, 0. That makes sense. But what happens when I try to mix this up? As in, what happens when I try to add the number 10 plus the string 20? What will happen? And the answer is, Actually, in this case, whenever we're adding a string plus a number, what JavaScript will do is JavaScript will say, well, you're trying to add one data type to another data type. I'm actually going to find the common ground for you. And this is a little bit of a memory thing, but just know that whenever you add a string to a number, what JavaScript's going to do is JavaScript is going to convert both things to a string first, and then I don't even want to say add it together, it will then concatenate it together. It will kind of shove it together as two strings. That's why on line 5, when I say the number 10 plus the string 20, what JavaScript's going to do is JavaScript's going to convert that 10 into a string of 1, 0, and then it will try to add those two strings of 1, 0 and 2, 0 together. And that's why on line 9, not sure becomes 1, 0, 2, 0. Okay, and so once again, we call this implicit coercion because nowhere on this page am I explicitly converting that 10 into a string, but JavaScript is doing it for me behind the scenes, or in this case, more appropriately, we should say it's using the plus operator to make that decision for us. Any questions there? Yeah, Katie?
Yes, I have a question. So after it turned into a string, the 10 to 20, if I was to console log the type of, would it give me as a number or a string back?
Yeah. And I'm going to do something here that you all should do as much as possible, which is whenever you have a question, just run the code. It will actually be the best practice in terms of sorry, I'm not saying for this question, like by all means ask me, but I'm saying like in general, if you're doing this by yourself and you're confused about what it should be, the best way to always make sure of any of this is just run the code. You will get the answer back as soon as humanly possible. Let me get this. Okay, great. So here, let's just run it to make sure everything still looks good. And yep, I have my sum of 30, my concatenated string of 1020, and my not sure. And so, Katie, your question is, if I console log out here, type of which variable?
Not sure because it concatenated.
Yep.
So it turned into a string but it's console log a number. So if I do that, would be a number back or a string back?
Yep. Right. So the answer is it's going to give you back a string. And the reason why is because what line 3 really is doing is when you add a number to a string, it will say, great, this is now this plus this, which becomes this, and that's a string, right? So this is equal to not sure. Make sense?
Yes.
Cool. Awesome. And let me just one of the really good things about REPL is it actually makes it really easy for people to share things too. So I'm just going to leave that there in case anyone wants to follow along or take a look at the code. Cool. All right. So this is implicit coercion. Once again, implicit because I never explicitly turned the 10 into a string, but the plus operator just kind of did it for me. It says, hey, you're trying to add a string plus a number. That means you want to add it. You want to convert everything to a string first before you add it together. And this is just a longer example of it. So let's go to line 7 then. On line 7, I'm trying to add the string 10 plus 20 plus 30 plus 40 plus 50. Who wants to venture a guess what this is going to give me? And if no one guesses, I'm just going to call on someone. Okay. Bianca, what is this going to give me?
I'm going to go with a string.
And what is a string? What's the value of the string? Sorry.
1, 0, 2, 0, 3, 0, 4, 0, 5, 0.
Okay, and why?
I'm guessing because whenever there's a string and a number, it's going to change it to a string.
Yep. Well, I guess the answer is given away up there, but let's just walk through this as a group. So here, let's comment out all of this up top. But yeah, let's now console log out. I thought it would auto-populate for me. What is this doing? Okay. Anywho, So there's that, and then let's also console log out type of. And so Bianca's intuition is correct. This does give us a string, and the reason why is because, and this is a pretty tricky thing to know, when computers execute code, right, they execute it usually top down, but they also execute it left to right. Or rather, sorry, if there's an equal sign in the equation, the computer will always try to evaluate the right-hand side of the equal sign first. But within the right-hand side, it will start left to right, the way that you and I read English. So when a computer tries to actually execute this line of code, it will actually try solving this part first. And so the first thing it will do is it will say, great, well, how do I solve 10 plus 20 plus 30 plus 40 plus 50? Well, the first way is just do, what's 10 plus 20? And what 10 plus 20 is becomes the string 10 plus a string 20. And so this, in fact, then gives us 1020. What does it do next? Well, the next thing we'll try to solve is, great, let's read it from left to right. Now what I want to solve is actually this. And that becomes the string 1020 plus the string 30, which gives us this fella here. And so on and so forth. And so I'm not going to go through all of it, but just know that when we do this enough times, at the very last step, we will get back a string of 10, 20, 30, 40, and 50, which is what we got over here. Okay? Does this make sense, everyone?
I have a question.
Yeah. Go ahead, Wilfredo.
If you change the position of that string, it changes everything, right?
Yeah, so
Doesn't the outcome change?
Yep, so this slide we just covered. So then I guess I'll ask you then, what happens here when on line 7 when I do this? 10 plus 20 plus 30 plus 40 plus the string 50. And I will
I don't remember.
well, it's not a memory test.
I want to say it changes into a number.
Okay. So what we call this? We call this also a string. Okay. So what do you think this will be? Or what do you think? What data type do you think it will be, and what value do you think it will be?
So I mean, I think it'll be a number.
Okay. And what do you think the value of the number is?
100.
100? Okay. Okay. Anyone disagree with the fact that they think that this also a string will be a number and the value will be 100?
I think it's going to be a string, and it's going to be 10050.
String, okay. And then the answer, so number or string, and this will be, and sorry, what was it? You said it would be a string and the value will be what?
10050.
Cool. All right, so let's run it and check. And the answer is it is 10050 and it is a string. So Bianca, why did you make that guess?
Because it's reading it from left to right, so it's going to add the numbers first and then turn it into a string when it adds the 50.
Yep, exactly. So remember what we said, that it will evaluate the right-hand side of this equal sign first, which is this part here, and it's going to read it from left to right. So the first thing it'll try to do is it will try doing something like this, which is, hey, what's 10 plus 20? And the answer is, well, 10 plus 20 is simply 30. Right? And then if we go from here, what does it try to do next? It'll say, well, let's take the next, person, or the next operation, which in this case is 30 plus 30. So then here we just go back to 60. And then lastly, 60 plus, or sorry, this will be 60. This will be plus 40. And so on and so forth. And so this will finally get back to us of 100. So everyone's with me so far, right? So what's 100 plus the string 50? Well, now we go back to our explicit coercion again, and say that or sorry, our implicit coercion again, and we'll say that, well, when I try to add 100 to the string 50, that actually becomes, what JavaScript is JavaScript is going to convert that 100 to that from a number 100 to the string 100 and add it to the string 50. And so therefore my final answer is going to be 10050. And this is also why my final thing is also a string as well. Make sense, everyone? Cool. Yeah, so I think that pretty much covers the implicit coercion in terms of changing it. One of the things that we've also see that we also tell people, and really it's just a best practice in all of JavaScript, is you might see some code written using the double equal sign, so the 2 equal signs, and you might also see other code being written with 3 equal signs. The reason why for that is because just because triple equal signs is 3 equal signs is a lot more precise than 2 equal signs. When you use 2 equal signs, what JavaScript is going to do is JavaScript is going to say, oh, let me try converting whatever you're comparing to the same data type first, and then check to see if they're equal. When you use triple equal signs, what it actually does is it just says, hey, whatever you're comparing, they have to be the same type, and they have to be the same value. So because it's a lot more precise and a lot more strict, usually as a best practice, you should only be using triple equal signs and never double equal signs, because double equal signs leave more room for error. And so yeah, without going too much into details of it, we just wanted to let you know why you should always use triple equal signs, and is because of this type coercion issue. Triple equal signs will always compare both type and value. Implicit or double equal signs will try to convert it to the same type if they're not the same type, and then compare the value. So it does a little bit more work for you, but by doing that work, it also introduces a lot of ambiguity. That's why on line 7 there, you'll see a blank string, double equals false. Well, that's actually true, because what's going to do is it's going to convert that string to a Boolean first. So it'll be false. It will convert everything to a Boolean, so it'll be false equals false, and that will give you true, which is why it does give you true. So yeah, TLDR, or the short version of this, is just to never use double equal signs, especially not for bootcamp prep. Okay. We've talked a lot about number coercion and string coercion, kind of how we go back and forth between those. But we also do Boolean conversion too. And just like the number class and the string class, where it's basically the name of the variable, except we capitalize the first letter, for Booleans, same exact thing. We have this Boolean class, and we know it's a class because the B in Boolean is capitalized there on the right-hand side of line 3. And so when I convert something to a Boolean, remember, a Boolean only has 2 possible values, true or false. And so when I convert something to a Boolean, I know I'm only going to get one of 2 possible values back, which is true or false. One kind of colloquialism in JavaScript is just that if I have a value that when I convert it into a Boolean, it becomes true, I call that thing truthy. And then if I convert something into a Boolean and it returns false, it's considered falsy. So not the most creative names, but hopefully pretty straightforward, right? Truthy and falsy. Or you might also hear people say truth-like or false-like. Same exact thing, no difference. So there's actually no need to tell you what's truthy in Boolean, because almost everything can be truthy. But it's a lot easier to tell you what's falsy in JavaScript, because once you know what's falsy, everything else, every other possible value or every other value you can possibly think of is going to be truthy. Okay, so the only values in JavaScript that are false when you convert it into a Boolean are empty string, the number 0, null, undefined, and on line 11 we have this thing called NaN, which is not a number. Not a number is what you get essentially when you try to convert something to a number, and it's not, and JavaScript couldn't do it. So if I try to do here, I try to console.log out. Okay, if I try to console log out number and I feed it in, the string, the string 12 or 1, 2, it's gonna say, great, here's 12. But if I try to feed in the string called David, it will give me back not a number. It will say, hey, look, I did my best trying to convert whatever it is you gave me to a number. I failed. I couldn't make it to a number. And so that's why it gives you back NaN. So that's what that is. And so once again, the only things in JavaScript that you need to memorize really in terms of Boolean coercion is just what returns false when I convert it into a Boolean. It is only these 5 things plus obviously false itself. So if I convert false to a Boolean, no surprise, it's also false. So these are the only 6 values that are falsy. Every other value, every other number or string or whatever or object or an array that you can think of, everything else is going to be truthy in JavaScript. And once again, that just means if I convert it into a Boolean, if it returns true, then I consider it to be truthy. Any questions here? Cool. If not, then one of the final things we're going to touch on is we've actually already seen Boolean coercion happen before in class, but I tried my best to not get too much in depth with it. But do you remember our if statement and our while loops and our for loops? Remember how we had those conditional expressions? And I said those are conditionals because at that point, as far as my loop is concerned, my while loop is concerned, or my if statement is concerned, there's only 2 possible choices, right? Either I do it or I don't. Either I run this code block or I don't. And so it doesn't actually matter what you put inside the parentheses. I mentioned JavaScript is going to do its best to convert it into a Boolean. That's exactly what Boolean coercion is it will try to take whatever value you give it and it will try converting into a Boolean. So on line 4 there, if I have an if loop, and rather than passing in, if this number is less than 5 or if this string equals David, if I just put in a 5, well, JavaScript's going to say, okay, what'd you put in between the parentheses? Oh, a 5. Great. Let me convert that 5 into a Boolean. Well, what's a number when I convert into a Boolean if the number isn't 0? Well, it's true, right? Because the only number that's the only number that's false when I convert into a Boolean is 0. So for every other number, 5 included, it's going to be true. So, and if on line 4, if my conditional is true, it means I execute a code block between lines 4 and 6. So when I run this code, I'm going to print out in the if. Similarly with a string, if I just put in the string apples, JavaScript's going to say, well, he gave me apples. Let's convert it into a Boolean, right? True or false. I don't care what apples is per se. I just need to know, am I running the code in the if block or not? And because apples is a string and the only false string, so to speak, is an empty string, and apples is clearly not an empty string, then that means that becomes true as well. And so when I run this code, this also console logs out in the if. Okay, so this is just to say that you've already seen it before where there are certain cases where a JavaScript or a computer might just say, you know what, like I don't care what you give me, I just care what it becomes eventually. And for if loops and while loops, it basically only cares that eventually will this become a true or will this become a false. That's it. So, yep, so that's a pretty clear example of how Boolean coercion is used in the wild. Any questions here? And because it's not enough, we just give you 10 more examples of this. So on the first one, is 10 true? Yep, so we're going to console log out yes. On line 10, is 0 true? Nope, it's false, so we're going to console log out the else. So same exact idea. Okay, the last thing we're going to talk about here is this exclamation mark operator, or what in programming is called the bang, B-A-N-G operator. What the bang operator basically does is you can think of it as you can put the bang operator in front of any variable you want, and what it will do is it will convert that variable into a Boolean and then give you the opposite of that Boolean. Sounds like a little bit of a brain twister, but let's see how we use it in real life. So on line 4 there, when I console log, if I was console log out true, it would get back true. But what's bang or what's exclamation mark true? Well, the exclamation mark is an operation. And what that basically tells JavaScript to do is, hey, look at true. Let's convert into a Boolean. Okay, so let's convert true into Boolean. It's also still true. And let's give you the opposite Boolean of that, right? So what's the opposite of true? It's false. And so in all of these examples here, when I put the exclamation mark or the bang operator in front of these things, for example, on line 8, when I do bang 100, well, the first thing I'll do is I'll say, great, take a look at 100. Let's convert that into a Boolean. Is 100 true or false? And the answer is it's true because it's a number and it's not 0. So therefore, it has to be true. And then it'll say, great, give me the opposite Boolean value of true. Well, what's the opposite of true? The opposite of true is false. And so on line 8, that's going to console log out false. And in fact, all of these console log out false because all of these, without the bang, these are all truthy values, right? These are all values that if I had to convert it into a Boolean, I would get back true. And then just to make things a little bit more confusing, you might also see something called a double bang, which is 2 exclamation marks in a row. And it basically does exactly what you think it does, which is it takes the opposite of the opposite. That is a little bit of a brain twister to think about in terms of trying to convert it. So I think the easiest way to think about a bang operator is to say, hey, whatever value you put the double bang in front of, all you're really doing is converting that value into a Boolean, right? So on line 6 for the string ABC, here let's actually just do it together. If I have if I have a console.logout and I console log out ABC, this console logs out ABC. If I was to console log out bang ABC, it will do is it will try to convert this into a Boolean, which is true, and give me the opposite of it, which is going to give me back. The computer should not get stuck right here. I don't know why it's stuck. Okay, false. And then as a next step, if I try to do double bang, it will say, great, convert this false into a Boolean and give me the opposite of that. Well, false converted to a Boolean is still false, and the opposite of false is true. So when I do a double bang of ABC, I get back true. In my mind, this is equivalent. In my mind, this is equivalent to just basically saying, hey, let's convert ABC into a Boolean. Right? These two are synonymous. They're making you do the same exact thing. And so the reason why, for example, we don't see triple bang is because if I have a value and I'm trying to convert it and I get the opposite of the opposite of the opposite, well, these two just kind of cancel each other out, right? So I'm still left with one bang. And so that's why you will only ever really see single bang or double bang and nothing more than that, because otherwise it just cancels each other out. This you can just think of as giving me the opposite of whatever my value currently is. And then this one you can think of as just saying, hey, this is the same as just converting whatever value I have into a Boolean. Oh. Does this make sense, everyone? Or rather, any questions?
So is there any reason to use the double bang instead of the Boolean operator class?
Let's see. Yeah, you type 5 less characters.
That's it?
Pretty much.
Okay.
Yeah. Sorry, not the greatest answer. Actually, no, you type 6 less characters because you also don't type a space either. So, time savings. Cool. All right, then let's keep moving. Oh, sorry. Did not mean to go through that one. And so if we go through our operators of kind of do or not do, the last kinds of operators are what we call the and the or operator, A and D and OR operators. And sorry, I keep saying this is the last one. These are actually the last ones we're going to talk about today. What the and operator does is it basically almost as a chain, it chains together and it checks in this case, and is something, you have a variable and another variable. What it'll do is it will check to make sure both things, once you convert into a Boolean, that both things return true or are truthy. Okay, so if I do on line 3, if I do 10 and 20, what it will do is it will say, great, 10, is that truthy? And the answer is yes, it is. Say, great, and 20, is 20 truthy? And the answer is yes. And only because both things are truthy does this whole operator return true, right? It's almost like saying, like, if I send someone to the grocery store to buy me milk and eggs, if they come back with just milk, it's not good enough. If they come back with just eggs, it's not good enough. They have to come back with milk and eggs for me to be satisfied, right? So if I have something like this, like 10 and 0, this basically means, great, is 10 truthy? Yes, it is. I'm so good, or so far so good. And then is 0 truthy? No, 0 is falsy. And so because the 0 failed this AND condition, this AND operator is going to return back false, right? It's like me sending someone to buy milk and groceries and someone asking me, hey, did this person complete their job? If they came back with only milk and no eggs, I'll say, nope, they didn't do their job. And they came back with only eggs and no milk, I'll say, nope, they didn't do their job. It's only if they come back with milk and eggs do I say, yeah, they did their job. Sorry, is my Wi-Fi? Am I cutting off for people, or do people hear me all right? You can hear me? Okay, cool. Awesome. All right, great. Sorry, I think, okay, maybe it's the visual that's lagging on my side then. So that's the AND operator. And just sorry, as a quick note here, I know I saw a few groups doing this yesterday too. If else, you don't need to specify any condition in the else, because all else means is, hey, the if condition didn't match, right? If you want to specify multiple conditions, look up something called the else if loop. That probably hits at what you want to do, but just know that whenever you see an if and an else, the else will never have any conditions after it, because by definition, the else is just the absence of passing the if statement. So in this case, we're saying if 10 and 0 is true, then console log out this message, else console log out 0 is falsy. Well, 10 is true, 0 is not, so therefore this AND operator gets back falsy or 0. And so because the if condition wasn't met, then by default I go to the else clause and I console log out 0 is falsy. Cool. And so as a last kind of thing to know, usually this is something you won't see as often, but just know that the AND operator returns either the first falsy value, or if everything is truthy, it will return back the last truthy value. So what that means is if I use an AND operator and I get back a falsy value, then I know at some point one of the things I'm testing for was false, and this is the first false it finds. The reason why it gives you back the first false that it comes across is because it's actually pretty efficient that way, in that if I have a list of conditions and every condition has to be met, as soon as I find the first condition that's not met, I actually don't need to check anything else on my list, right? If I give you a list of 5 things to buy and I need all 5, and I go to and you bought the first one but not the second item, I don't really need to check items 3, 4, and 5 because it doesn't matter, right? You've already kind of missed the opportunity to buy everything. So what AND does is saying, hey, if I come across the one false value, I'm gonna stop right there and say, I don't need to check anything else because there's no point. You have not met every condition. So AND will return back the first falsy value or the last value if everything is truthy. And so just 2 more examples of this then. For 10 and apples and 0 and null, the way that the JavaScript will read this is say, great, let's check 10 first. Is 10 truthy? Yep, great, let's keep going. Is apples truthy? Yep, let's keep going. 0, is 0 truthy? No, 0 is falsy? Great. At that point, it will return 0, and that's what we store in the return value 1. Similarly, on line 7, we'll say, great, let's check these 3 things. Is the string lucky truthy? Yes. Let's check the next thing. Is the string number truthy? Yes. And then lastly, is a number 7 truthy? And the answer is yes as well. So I'm going to give you back 7. where I'm going to capture 7 in the return value 2, because once again on line 5, I'm giving you the first falsy value I found, and on the second, on line 8 there, I'm giving you back a truthy value, which means everything else in this list was truthy. Notice how in line 4, there's a null that comes after the 0. That's also falsy. But once again, we never check that, right? Because we hit the 0 and say, well, if 0 is falsy, there's no point in checking anything after it because I'm going to return false no matter what. Right? So it might seem a little bit tricky to think about first, but just know that like this is something that like it hopefully should also make sense in real life too. If I just take a second and think about it when you're doing these types of problems. And then the cousin to and is or, right? And or basically is the mirror inverse of and. And what or will say is that if so in real life, once again, go back to the grocery example, if I give you 5 things to buy and say, hey, buy me milk or eggs or bread, well, as long as you give me back any of those 3 things, I'm super happy, right? I'm satisfied. And so what or does is or will return back the first truthy value because it'll say, oh, great, you bought me at least one of these 3 things. I actually don't care about the other 2 because you bought me at least one. Or if everything is false, it will give you back the last value, which basically says, hey, none of the conditions you want were met. And so here, if I have on line 4, if I have an example of no and undefined and happy and pumpkin, then the or operator says, great, let's check null first. Is null true? Nope, it's not. Okay, well, that's fine because there's still a possibility that the next thing is true. Next thing is undefined. Is undefined true? And there's no, it's not. Okay, well, let's keep checking because there's an option the next thing could be true too. Next thing is happy. Is happy true? Yes, it is because it's a string. And so therefore, it will stop at that point and say, I have all the information I need to know that at least one of the things in this list is truthy. And so we capture happy and return value 1. And then similarly down here on line 7, we check again, is false falsy? Yep. So let's check the next one. No, is null falsy? Yes, it is. Okay, what's next? Is 10 less than 0? No, it's not. And then last, it checks now a number. Is now a number truthy? No, it's not. So we basically went through all 4 things and verified that all 4 are false. So then the last false thing we encounter, that's what gets returned. And so return value 2 becomes not a number. And once again, the reason for that is just because on line 4, we're giving you back the first truthy value we found. And then if everything is false, then we will give you back the last falsy thing that we found. And that's pretty much it. We covered types, we covered coercion, both explicit and implicit. We talked about truthing, or we talked about comparisons and why you should always use triple equal signs and never double equal signs. We talked about Boolean coercion, so converting things into either true or false, and what is truthy and what is falsy. We talked a little bit about conditional operators, which we've already seen in the if loop and the while loops. And then the last 2 things we talked about are the bang and the double bang operators, as well as the and or operators. So quite a bit of content, but once you get a hang of it, it actually is, in my opinion, fairly intuitive, because it all follows kind of very human logic, right? Like these are things that we've introduced because it's easier on people. It's actually easier. It makes it easier for people to understand what's going on. So any questions from the topics we covered today? Yes, there is a question. Oh, sorry. Sorry, Martin. Sounds good. Okay. Any questions on the topics for today? See, you're really getting in the mood, Martin. All right, then. I will break you off into groups. Oh, yeah. Happy Halloween. Sorry, totally slipped my mind. And I will break you off into groups, and then yeah, I will. Me and I think Samir is a fellow for tonight. Once you get in a group, start working. Feel free to use CodePen, or if you want to copy your code into REPL and run it there, equally fine. I think REPL is a little bit of a cleaner thing to understand if you have any syntax errors. But otherwise, we'll probably check in half an hour to 45 minutes to make sure everyone is on the right track. And let us know if any questions, right? Cool.